Okay, now let's take a look at a parallel circuit and how we would analyze this circuit and find the voltage, the current, and the resistance for each of the elements on the circuit and for the circuit as a whole. Now, we have a parallel circuit, and you want to have two things at your ready here, a calculator, and you want to somewhere have access to your circuit rules, okay? Now this could be in your OneNote. You could maybe put this on an index card so that you always kind of have access to it. You have, you can take a screenshot, put it on your phone so you always can see it. But these rules are everything. They're what give you the rules to kind of live by as you go through and you analyze each component. Now we're in a parallel circuit, so remember we're following this column. And in a parallel circuit, the voltage across one component is the same as the voltage across every other component. So if I know the voltage of any element in the circuit, I know the voltage of every element in the circuit, which is awesome. My current, my conventional current, the total current, that's the current across the battery or the power source, is going to be equal to the current across the first branch plus the current across the second plus the current across the third. And then I have that weird equation for the equivalent resistance, where I am taking 1 over each resistor's resistance and adding them up and then inverting it, essentially. So we will talk about this. Sometimes you can avoid having to deal with this. It's not difficult, it's just tedious. But sometimes you can avoid dealing with this. Other times you've just got to do the math out, and I'll show you both ways on our example here. So you want to have your rules handy, you want to set them aside, and let's get started. First of all, everything revolves around Ohm's law, which tells us that the voltage is equal to the current times the resistance, V equals IR. And we can solve for, any one of these variables if we know the other two. Looking across our circuit here, I'm going to cross these little K's out. They don't need to be there. They're just going to make everything complicated. And we don't like complicated. We like easy. We have a 9-volt battery. We have a 3-branch parallel circuit. Each branch has a single resistor, and we do have the resistance of all 3 resistors. That's nice. But we know nothing about the currents through each of those. We know nothing about the current and the equivalent resistance, the total resistance on the circuit here. So, where do we begin? First of all, always take all of your values and write them into your table. So for example, my total, this is V total. My total voltage is going to be 9 volts. My first resistance, my resistor is going to be 10 ohms. My second resistor is 2 ohms. And my third resistor has a resistance of 1 ohm. And that is everything that I know. Okie doke. Well, first of all, it's always nice when you have the voltage in a parallel circuit, because if the voltage is 9 volts at the battery, it has to be 9 volts everywhere. So I can just write 9 volts in, like such. And it's like magic. All of a sudden, I can easily calculate the current at each of the 3 branches, the resistors at each of the 3 branches, because I have 2 of the 3 variables in Ohm's law. Now, I can do this by rewriting Ohm's law to solve for I. I just divide both sides of the equation by R to get I by itself, and I end up with I1 is going to be equal to V1 divided by R1. That is going to be equal to 9 volts divided by 10 ohms. So I1, the current at resistor 1, is going to be equal to 0.9 amps. And I can write that in. Same thing for resistor 2. I2 is going to be equal to V2 over R2, which is going to be equal to 9 volts divided by 2 ohms. I2 is going to be equal to 4.5 amps. I can write that in. Okay, my third resistor, I have I3, current at 3 is going to be equal to the voltage at 3 divided by the resistance of resistor 3. That is going to be equal to 9 volts divided by 1 ohm. I3 is equal to 9 amps. Well, that wasn't so bad. Now, total, remember my circuit rule, total current in a parallel circuit is simply equal to all of the currents added together. So I total is going to be equal to I1 plus I2 plus I3, which is going to be equal to, what do we have? 0.9 amps plus 4.5 amps plus 9 amps. So I total is going to be equal to 14.4 amps. And I just did that really fast, so let me know if I got that wrong. I total 14.4 amps. Now I said earlier that if you're lucky, you don't have to mess around with the equivalent resistance, because you're just going to get it because you have V here, total, you have I total, you can just solve for R, okay? And so our equivalent resistance, I'm just going to do it right here, is just going to be equal to V total over I total. And that's going to be equal to, I'm running out of space, 9 volts divided by 14.4 amps. And I'm going to do my math and hope that my camera has been shutting down on me. So 9 divided by 14.4 equals 0.63, equals 0.63 ohms. Yikes, that's supposed to be an ohm. Okay, so I'm just going to put a little box there because I want to show you how would you actually do this if you were just trying to use these resistors to calculate the equivalent resistance. I'm going to do that right up here. So resistance equivalent is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3, and then we're going to invert the whole thing. Okay, 1 over R1 is 1 over 10 plus 1 over 2 ohms plus 1 over 1 ohm. Sorry, I made like a weird loopy ohm there. And then to the negative 1. So I have 0.1 plus 0.5 plus 1, right? All to the negative 1. So basically what I have here is 1.6 to the negative 1, which is equal to 1 divided by 1.6, which when I do that, 1 divided by 1.6, boom, 0.625. So 0.63 ohms. Samesies. Good news. 0.63 ohms, and this circuit is solved twice.